In this session, we are looking at radioactive half-life, which is the time taken for radioactive particles to reduce to half the original quantity or number. Welcome. So assuming that we are given 5,600 units of carbon-14 and they happen to decay to 175 units after 150 years, could we find the half-life of carbon-14? Let's assume this happened in a tree or some fossil. So what we will do is simply to say that we had 5,600 particles. They are decaying in halves. That is what is known as half-life. So each time we divide by 2, in this case we'll get 2,800. Divide by 2 again, that is the second half-life. We would end up getting 1,400. Divide by 2 yet again. What we have there is 700 particles. Divide by 2 again, we get 350 particles. Divide that by 2, finally we get 175 as the remnant particles. So if you look at it keenly, we have divided by 2 5 times. 1, 2, 3, 4, 5. This shows that there are 5 half-lives. So we can say that 5 half-lives happened in 150 years. How about 1 half-life? It will happen after how long? So by cross multiplication, we have 150 times 1 over 5, which gives us 30 years. And that means the half-life of carbon-14 is 30 years, as alluded to in the question. So half-life is the time taken for radioactive particles to reduce by a half their original number. And looking at it from another dimension, we could say if this were 30 years, it took 30 years for 5,600 particles to reduce to 2,800. It will take 30 years for each successive reduction by a half. So we'll have 30 years, 30 years, 30 years, and you'll find that the total is 30 times 2, 3, 4, 30 times 5, which is 150 years. So it takes 150 years for 5,600 particles of carbon-14 to reduce to 175 particles. Next, we have a second question which says, find the percentage of carbon-14 in a wasting fossil after 90 years, given that the half-life has been quantified as 30 years. So we can say the original quantity, the original percentage is 100. So the same way, this 100 is going to reduce a given number of times until after 90 years. Now, the half-life is 30 years. So after 90 years, how many half-lives are there? We have 90 over 30, which is equivalent to 3 half-lives. So given there are 3 half-lives, we are going to proceed and say that if the original percentage was 100, so the 100 is going to be divided by 2 3 times. So we can say that out of the 100%, we divide by 2 the first time, we get 50. We divide by 2 a second time, we get 25. We divide by 2 the third time, and what we get is 12. 12.5. So 12.5 will be the final percentage of particles remaining after 3 successive half-lives, spanning through 90 years, given that the half-life is 30 years. In our third case, we are being given another question, and this is similar but not identical. So the third question says, find the original number of isotopes given that 20 grams are left after 32 seconds. Yeah, left after 32 seconds. So number 3, 20 grams of a radioisotope of half-life 4 seconds remains after 32 seconds. So what is the original number? Remember, this represents half-life. So that's the half-life is 4 seconds. After 32 seconds, 20 grams remained. So what is the original number? So we could say that time taken is 32 seconds. The half-life is 4 seconds. So what are the number of half-lives? Simply 32 over 4, which is 8. So we have 8 half-lives. So from these 8 half-lives, we can say that the reverse is expected to have occurred, that the original number reduced successively from x by 2 8 times, and when that 8 times happened, it gave us 20. Good, it gives us 20. So what is the value of x? This simply would mean x is 20 times 2 power 8. And when you do that mathematically, we say 20 times 2 power 8. Yeah, we get 5,120 particles, which is the initial number. We can confirm that, if you allow me, just briefly, to show how this happened. It means there are 5,120 reduced by 2. When you divide that by 2, you get 2560. Reduced by 2 a second time, we get 1280. Reduced by 2 8 times, so we get 640 there. Divide by 2 again. So this is the first, the second, the third. So on the third we get 320. Reduced by 2, what do we get? 160. On the fourth. Reduced by 2 on the fifth. divide by 2, we get 80. Reduce by 2 on the 6th. So reduce by 2 on the 6th, we get 40. Reduce by 2 on the 7th, we get 20. So 1, 2, 3, 4, 5, 6, 7. So those are 7 half-lives. So well, proceeding to the next question, which is number 4. So in our number 4, we are told that 1/8 of radium isotopes of radioisotope palladium remained after 24 seconds. Find the half-life. We say find the half-life of the radioisotope. So that is a question. So as we look at this, 1/8 remains after 24 seconds, and we are required to find the half-life. So we can say the solution will be from a whole. If we are talking of 1/8, 1/8 is a fraction of a whole, and a whole is 1. So the solution is the original number is 1. The final number is 1/8. And then time taken is 24 seconds. So the question is, what is the half-life? So to answer this question, we need to find how many half-lives will reduce 1 into 1/8. So to reduce 1 into 1/8 is 1 over 2 power x is equals to 1/8. Yeah, that is mathematical. So to find x will be the number of times it was reducing by halves. So in this case, we can rewrite this as 2 power minus x is the same as 8 power minus 1. Good. And then we can rewrite 2 power minus x is the same as 2 power minus 3. Now the base of the indices is the same, so we have minus 3 is the same as minus x is the same as minus 3. In this case, the negative and negative cancel, so we have x is 3, which means 3 half-lives. So from 3 half-lives, we have 24 seconds. If you allow me to use this upper part, we can say that 3 half-lives is 24 seconds. How about 1 half-life? That will be 1 times 24 all over 3. So that gives us 8 seconds. Good. So the half-life of this species is 8 seconds. And that basically is what we are referring to as the half-life. We have said that half-life is the time taken for a given radioactive species to reduce into a half their original number. And we can use the half-life to quantify the age of a species such as a dead tree or dead fossil. Thank you.